Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what is the parallelogram law of forces, and I'm going to solve some of the problems based on this law of parallelogram of forces by using analytical method. Now here, what is the parallelogram law of forces? It states that if two forces are acting on a particle or on a body, the effect of these two forces here, if we consider it, P and Q forces are acting on a particle O and making an angle between these two forces is alpha. The effect of these two forces will be represented by a single force. That force is known as the resultant force. This force is the diagonal. Suppose if we consider the forces, these two forces are two sides of a parallelogram. In figure 1 here in this C, if you see here, the P force and the Q are acting as a two sides of parallelogram. Then the diagonal represents the resultant of these two forces by making an angle of theta with the vector force, that is the P. So that is a graphical method. By analytical method, if we understand that, if you draw a perpendicular line, that is CD, to the extension of OA, that is AD, the angle made here, that is alpha, because the P diagonal, the side of OB is making with the side of OA is angle alpha. So this AC is a parallel to OB, all right. So the angle with the horizontal, the same sides is the similar triangle, similar angles, that is alpha. So by using this AD, that is the horizontal component, this is the Q. AC cos alpha, AD equal to AC. AD equal to AC equal to Q. That means AD equal to AC cos alpha, that is Q cos alpha. Whereas CD, vertical component, perpendicular component, CD equal to AC sin alpha, that is Q sin alpha. But we know another right angle triangle, that is OCD or ODC is the right angle triangle. According to Pythagoras theorem, OC square, diagonal side square equal to opposite side square plus adjacent side square, that is CD square plus OD square. What is here OD? The OD equal to OA plus AD. This OA plus AD, what is that OA? OA equal to P. What is AD? AD equal to Q cos alpha. And CD equal to Q sin alpha. If you substitute in that theorem the terms, that is OC square equal to OD square plus DC square or CD square. What is OC square? The OC equal to R square equal to, what is OD? OD equal to OA plus AD, that is P plus Q cos alpha. P plus Q cos alpha. And what is it? CD. CD DC equal to AC sin alpha, that is Q sin alpha. Substitute over here and simplify it. Then the equation obtained, the resultant equal to the resultant force equal to under square root of P square plus Q square plus 2PQ cos alpha, where alpha is the angle made between OA and OB. OA and OB. Angle made between OA and OB, and P is the force horizontal, that one of the side, that is OA. And whereas the Q is another force, that is Q. P and Q, when it is acting on the particle O, the resultant force are equal to under square root of P square plus Q square plus 2PQ cos alpha. Alright. What is the magnitude theta? The theta, if we understand from the right angle triangle, that is OCD, from that OCD triangle, tan theta equal to opposite side by adjacent side, that is a CD by OD. What is the CD? The CD equal to Q times sin alpha. What is OD? OD equal to P plus Q cos alpha. So tan theta equal to Q sin alpha by P plus Q times P plus Q cos alpha. That is theta equal to tan inverse of q sin alpha by p plus q cos alpha. That is a q sin alpha by p plus q cos alpha. This equation gives the direction of the resultant. What is the direction? At what angle this resultant force is acting? This force is acting. Now here theta, the theta, this R is making, R is the resultant force which is made with the angle of, that is tan inverse of q sin alpha by p plus q cos alpha. This theta is the direction of resultant R. Now by using these two derived expressions, we are going to calculate some of the unknowns, objectives. Now let us begin with a problem that is a direct problem here. So simple. Provided, if you remember the formula, that is R equal to P square plus Q square plus 2PQ cos alpha. And one more, that is theta equal to the direction tan inverse of Q times sin alpha by P plus Q cos alpha. If you remember these two expressions, we can solve any problem or any sum related to the parallelogram law of forces. So here, what is the problem? What is the here? The two forces of magnitude 10 newtons and 8 newtons are acting at a point, If the angle between these two forces is 60 degree, that is alpha equal to 60 degree, determine the magnitude of the resultant force. That's what it is asked, only magnitude of the resultant force, R. Now if we consider 10 newtons is the P equal to 10 newtons, Q equal to 8 newtons. And the angle between them, P and Q, how much? That is a 60 degree is the angle, alpha equal to 60 degree. Yeah, what is the resultant force? The formula expression is resultant force R equal to under square root of P square plus Q square plus 2PQ cos alpha. What is the P value? The value of the P is 10 newtons. Value of the Q is 8 newtons. Substitute over here. That's it. Very simple. So P square equal to 10, Q equal to 8, 2PQ 2 times P 10, Q 8 cos alpha, that is 60 degree. So what is cos 60? 1 by 2. That is P square, 100 square, that is 10 square equal to 100, 8 square is 64, 2PQ, that is 2 times P, that is 10 times, P is 10, Q is 8, that is cos 60 1 by 2. That is under square root of 244. The values obtained as 15.62 newtons. That is the answer. The objective here it is the magnitude of resultant force. That is 15.62 newtons. R equal to 15.62 newtons. That's what the objective we calculated here. When two forces are acting, the two forces are 10 newtons and 8 newtons. The angle between them is 60 degree. The resultant force by these two forces are replaced by a single force. That is the resultant force is 15.62 newtons. And what is the angle? What is the direction of that resultant force? That is not asked here. If you want to find out the direction of the resultant force, that is theta equal to tan inverse of q sin alpha. That is tan inverse of, what is the q sin alpha? What is the q value here? 8 newtons. Sin alpha, alpha is 60 degree by P plus 10 plus Q, 8 cos 60 degree. If you calculate it, this is the angle with which the resultant force is acting on your body. That is the resultant force here. R equal to 15.62 newtons is the resultant force, and the direction is the tan inverse of 8 times sin 60 by 10 plus 8 cos 60. This is the what is that? The direction of the resultant force. The next problem, next. Here, very important, let us start next problem number 2. Two equal forces are acting at a point, same, with an angle of 60 degree, that is alpha between them. If the resultant force is, calculated resultant force is 20 times root 3 newtons. Find magnitude of each force. So here alpha equal to 60 degree and the resultant force R equal to 20 times root 3. But we need to find out what is the P value and what is the Q value. But here it is the two equal forces. The two equal forces are acting. That means P equal to Q. P equal to Q. For that case, how to find out the resultant force, or how to find out the two forces, that is the P equal to Q. If we find out one force, we can know that equal to Q. So what is the magnitude of each force? If we know the P or Q, that means each force P equal to Q equal to so and so value. So this is the case of when two forces are equal, the angle made between them is 60 degree and we know the resultant force. Let us begin. Here, when two forces are equal, when equal to between the two forces are equal and it is made with 60 degree or having some angle alpha, for that we already derived expression, the resultant force R equal to 2p times cos alpha by 2. Okay, here what is the P value? P is the unknown, P is to be calculated and R is known. The R equal to 20 times root 3, 2p times cos alpha by 2, cos 60 by 2, that is cos 30 degree. That is 2p cos 30. What is cos 30 equal to root 3 by 2? 2p times root 3 by 2, that is 20 times root 3 equal to 2p times root 3 by 2. So here that is nothing but p times root 3. 2p times root 3 by 2, 2 will be cancelled, that is p times root 3. Then p times root 3, root 3 cancel, then p equal to 20 newtons. So the magnitude that p equal to 20 newtons and q also 20 newtons because equal force. The p equal to q equal to 20 newtons. Alright. This is one of the method. What is another method? So we are going to solve. If we know the formula, direct expression we know for this case study, here we substituted. We don't know the expression, how to get, how to reach, how to obtain this expression from the concepts of parallelogram law of forces. We know the resultant force when the two forces are P and Q, the angle between them is alpha, then the resultant force formula is P square plus Q square plus 2PQ cos alpha. Now the case here it is P equal to Q and the alpha equal to 60 degree. When P equal to Q, then P square plus 2P square cos alpha. Then what will happen here, that P square plus 2P square cos alpha are equal to, then here it is 2P square plus 2P square cos alpha are equal to. Next, here substitute R equal to, no problem, R equal to, what is the R equal to 20 times root 3. Then under square root of 2p square plus 2p square cos alpha. What is that? Alpha equal to cos 60. Now 20 times root 3 equal to 2p square plus 2p square. What is cos 60? That is 1 by 2. 2 get cancelled here under square root. That is 2p square plus p square, 3p square under square root of, that is 20 times root 3. So it becomes root 3p equal to 20 times root 3. Alright. Now root 3 get cancelled. Then p equal to 20 newtons. Calculation here. So P equal to 20 newtons, then P equal to Q, equal no each force. That means P equal to that 20 newtons equal to Q force. So P equal to Q, that equal to 20 newtons, that is the each force. That is the objective we found here. P equal to Q equal to 20 newtons. But there is here, what is the direction with which? Yeah, this resultant force, no. The P and Q is a 20, that is the objective asked here. It is obtained in this manner. Here in this problem, we solved by using two methods. One is we applied directly the concepts which we are expressed the resultant force by using the resultant force when two forces are acting P and Q, angle between them is alpha. By using that formula, that is R equal to under square root of P square plus Q square plus 2PQ cos alpha. By using that expression, we solve the problem. And also, in previous lectures, we derived expressions for different cases. So one of the cases when two unequal forces and having the angle between them is alpha, for that resultant we have derived expression that is R equal to 2p times cos alpha by 2. This expression was derived from the expression of R equal to under square root of p square plus q square plus 2pq cos alpha. The expression of R equal to 2p times cos alpha by 2 is derived from the expression by using the expression of R equal to under square root of p square plus q square plus 2pq cos alpha. Alright. So this expression derived by using this expression. By using that expression we achieved the same answer as we have calculated already derived expression using. That is what R equal to 2p cos alpha by, that is 20 newtons. Here by using this method also 20 newtons. Alright. So the main thing is that no need to memorize various so many expressions. We have to remember the derived main source of expression, that is R equal to under square root of p square plus q square plus 2pq cos alpha. Okay. Coming to next problem. So very important. We are going to solve this problem. The next step, little bit more deeper, we are getting into that. Let us start. The resultant of two forces, when they act at an angle of 60 degree is 14 newtons. Okay, if the same forces are acting at right angles, the resultant is 130 under square root of 136 newtons. Here alpha 1 equal to 60 degree and R1 equal to 14 newtons. And alpha 2 equal to 90 degree. If alpha equal alpha 2, then R2 equal to under square root of 136 newtons. Now we have to determine the magnitude of two forces. Determine the magnitude of the two forces. That means what is Pu, what is P and what is Q. Okay. Now we know the derived expression when the angle is equal or not equal or 90 degrees. Next, what is the expression for the case 1? R equal to under square root of p square plus q square plus 2pq cos alpha. Here, the p is not equal to q. Alright? But alpha equal to 60 degree and R1 equal, that R becomes R1, that is 14 newtons. Substitute here 14 newtons equal to under square root of p square plus q square plus 2pq cos times alpha, that alpha equal to 60 degree, cos alpha 60 degree. Now the expression here 2 will be cancelled, p square plus q square plus pq under square root of. So make it square root both the sides, that is 14 whole square equal to, then becomes square root and square will be cancelled, that 196 equal to p square plus q square plus 2pq. That is the case 1 equation 1. The next case 2, using the equation for case 2, what is R equal to? How it becomes R equal to p square plus q square? Let us consider. What is the case 2 here? The case 2, first derived source expression is p square plus q square plus 2pq cos alpha. For applying case 2, the given condition is that alpha equal to 90 degree, perpendicular each other. The angle, right angles, acting at right angles, alpha becomes alpha 2, that is 90 degree, R2 equal to 136. Alpha equal to 90 degree and R here it is under square root of 136. Now substitute alpha equal to 90 degree. Before going to substitute a resultant value, when cos alpha equal to 90, that becomes 2pq, it becomes 0. that is under square root of p square plus 2pq cos 90. As we know, 90 cos 90 equal to 0, then it term becomes cancelled. Then that is p square plus q square, that is r equal to. Now substitute, this is the expression derived from the derived expression, that is a new expression when p and q are acting 90 degrees each to each other. That r equal under square root of p square plus q square, that r equal to under square root 136 equal to under square root of p square plus q square. By squaring on the both sides, 136 equal to p square plus q square. Okay. Now we know the equation 1. What is the equation 1? The equation 1 is that 196 equal to p square plus q square plus pq. Alright. Now here substitute this equation 2 in equation 1. Then or subtract from it. There are various methods are there in algebra. We can also do it. But the way we followed methodology, substitute this p square plus q square, we have to subtract from equation 1. Then 196 minus 136 equal to p square plus q square plus pq minus of p square plus q square. This p square plus q square plus and minus positive and negative will be cancelled. Then pq equal to 60. Now 60 equal to pq. Now, okay, we know the equation multiplying. Yes, the above equation we get the if we equate by 2 and both sides LH and RHS, then what will happen? 2 times 60, that is 120 equal to 2 times PQ. That means 2 PQ equal to 120. Sorry, 120. Substitute. Again, adding equation 4 to equation 2. This is the equation 4. Make it adding to equation 2. What is the equation 2? This is the equation 2. What is the equation 2? 136 equal to p square plus q square. If we add equation 136, so 136 plus 120 equal to p square plus q square plus, what happened here? 2pq. Now what is the p square plus q square plus 2pq equal to p plus q whole square, that equal to 136 plus, that is it becomes 256. From that p plus q equal to under square root of 256, that becomes 16. P plus q equal to 16. Okay, then it becomes 16. Then p equal to, what is the p equal to? 16 minus, p equal to 16 minus q. This is the equation 5. 16 minus q. Now, further simplification, we know the equation 3. What is the pq equal to 60? So, pq equal to 60. And here 60, not 60 degrees. Here 60, we know the p equal to what? What is the p value? Just now we expressed here. P value equal to 16 minus q. Substitute here. P value 16 minus q. 16 minus q times q equal to 60. It is like a quadratic equation. If we simplify it, that is q square minus 16q plus 60 equal to 0. This is a quadratic equation. When the quadratic equation is in this form, we want to find out the q value. Suppose when the equation is ax square plus bx plus c equal to 0, then what will happen here? What is the roots of x equal to? Minus b plus or minus under square root of b square minus 4ac by 2a. Okay. Now here, if you substitute, by using this formula, similarly, the equation q square minus 16q plus 60, what is a value? A equal to 1, b equal to minus 16, c equal to 60. Substitute over here, minus b, minus of minus plus, minus b plus or minus b square minus 4ac, a equal to 1, c equal to 60 by 2a, 2 times a1. So, the values obtained for q equal to 16 plus 4 by 2 and 16 minus 4 by 2. What is 16 plus 4 by 2? 16 minus 4 by 16 plus 4 by, that is 20 by 2 is the 10. Okay. And 16 minus 4, 12 by 2 is the 6. So, substituting the values of the Q in equation 5, where is the equation 5? Yes, we will get it P equal to how much? Again, we know what is that value. Either any one of the equation, if you substitute Q value, either PQ equal to 60 or P equal to 16 minus Q. The values obtained, P values are 16 and 10. So, the forces are what here? Q value equal to 10 and 6. P values are 6 and 10. What are the values of P and Q? The value of the P is the maximum larger value, that is P equal to 10 newtons and Q equal to 6 newtons. So these are objectives are achieved. The values of P and Q. P value equal to 10, the value of Q equal to 6 newtons. Now what is the resultant here? If you apply by considering these two forces, you can validate. Then R equal to, what is the R equal to? If you substitute back, obtained values are 10 newtons and 6 newtons. If you substitute back, R equal to under square root of P square plus Q square plus 2PQ cos alpha. For the first case, what is the first case here? The first case here it is 60 degree is the alpha equal to 60 degree. Then what is the resultant should be obtained? 15 newtons should be obtained. Then substitute P equal to 10, that is 10 square plus 6 square plus 2 times 10 times 6 times cos alpha, cos 60 degree. What should be R? R should be become 14 newtons should be obtained. So the R value here, that is 100 plus 36 plus 2 times. If we can make it 10 times, because cos 60 is 1 by 2, 2 to get cancelled, that is 60. It becomes how many things? 196 equal to 14 newtons. R equal to 14 newtons. Okay. Now what about next value? The next case study, if you want to validate it, what is the second case should be validated? Then when it is 90 degree, again P square plus Q square plus 2PQ cos 90 degree, because 9 perpendicular to each other. The resultant should be obtained how much? Under square root of 136 newtons. That is here P square, P equal to 10. 10 square plus Q, 6 square plus 2 times 10 times 6 times cos 90. Cos 90 becomes 0. This value term becomes 0. What is 100 plus 636? That is under square root of 136. This is the validation. We got it. Resultant for second case. Case 2 resultant should be under square root of 136. And case 1, that is the K for case 1. We got it. Case 1 R. That R equal to how much? That is 14 newtons obtained. So in this manner, we have to calculate. We calculated here. We have to calculate the resultants of forces, that is P and Q. When here is the reverse process, the resultant were given and alpha data was also given. So it's a very, very important model for practicing. So that here, one more thing is that the inputs are here. Alpha is the input. Alpha, that is on resultant forces. And alpha equal to 90 degree and resultant forces are 1 under square root of 136. The case 1 and the case 2. By using case 1 and case 2, we have to calculate the magnitudes of the forces which are acting. The resultant magnitude of the two forces, that P and Q, are calculated. The calculated forces P and Q, that is 10 newtons and 6 newtons, are calculated. In this problem, we calculated analytically and also we verified it whether by using these two forces P and Q, the resultant force is being obtained or not. That is R equal to 14 newtons for case 1 is obtained here, and also the for case 2 resultant force is under square root of 136 newtons. Alright. This is what we calculated by using the parallelogram of law of forces and derived expressions. We derived expressions also. We used derived expressions such as resultant force are equal to p square under square root of p square plus 2pq square plus 2pq cos alpha, and also the direction tan inverse of q times sine alpha by p plus q cos alpha. These two derived expressions. Okay, let me conclude in this session. In this session, we discussed what is a parallelogram of law of forces, both graphical method and also analytical method. And we solved the three models, three types of problems. The basic one, first level, second level, and third level of problems we solved in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.